And here I am. So it says latency is low, but it is not low. So since the last stream this morning, I've changed and rewrote the script probably to show the DMM measurements, which you probably see on the right. But today we will work on this device. So I'm working with a bar club, a private bar club, and I've created the crown counter. So there's a typo here, but I left it in afterwards because I thought it was fun. And the idea behind the crown counter is that it displays how many caps have been used or inserted, so how many beer bottles mainly have been used. So you have the total from the beginning on and what is today. And it works by having this sensor, and this sensor is in the basket. So you have the bottle opener, let's do it this way. You have the bottle opener right here. So when you open the bottle, you open it yourself, the bar doesn't open it. Then the crown, or the beer cap, goes in here. And this should detect when the beer cap goes in there. And if it goes here, back, here I'll use it. I'll use coins because I don't have any crowns anymore here. Then it should count upwards. And this should kind of work. Well, it worked when I created it and tested it for 10 minutes. Then I installed it, and over time it just lost count. Well, it doesn't lost count, it had lots of false positives. So let's remove this also. Let's get rid of the screws. And yeah, I'll show you afterwards how it's, what is inside. So what is inside is not particularly hard. Here we have the microcontroller. This is a Blackbill, so it's an STM. Why is there a dot here? STM32F4. We have two 7-segment displays. These are TM1637, which you can control using these lines. And one is not working normally. And here we have one battery. This battery is to provide power to the real-time clock because I need to count days. It shows what is today and this shows what is in total. So I need to count days. And this battery will keep the RTC running and also the SRAM. So even if this is not powered, it still counts days, and the number of caps is stored in SRAM. So even if there's no power, I don't have EEPROM, I write it into the SRAM. It's a lot more volatile, less volatile than EEPROM. So see, this display is already broken, and this is probably. So let's see. So there are two things, yeah. Why it shows only two? That shouldn't be two. 3. See, there's lots of false positives. I'll explain the mechanism afterwards. But this display doesn't work. Is it? Yeah. Yeah. We have two cables which are broken on the bottom of the display. So I will need to add also some glue on these pins. I'm not sure I will fix it because there's glue here. So let's get the glue gun and let's fix this. So this was not broken in the bar. I broke this when I tried to debug it. Up. How will I fix that? Because I will cut all the leads. I will try with the desoldering gun to remove it. So it's basically an easy project normally, but the details are harsh. Up. Yeah. Okay, let's cut them again. Let's switch off the power so I don't short anything while I cut. I don't know what is what, but probably the colors are the same also on the other side. Let's switch on the soldering iron. I'll need it. Up. 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 Soldering iron. Let's water the sponge. and some solder. And I need to desolder this, but the heating gun takes a lot more time than the soldering iron. So soldering iron ready? Yep, soldering iron ready. On some reviews you see that the time the first, how fast it heats up from start. I think it's not that important. It gives a good indication on how powerful the soldering iron is, that's true. But when you solder, you have waiting between 10 seconds and 30 seconds is not that much of a pain if you have a long solder session. But yeah, it gives an indication of how fast it heats, of how fast it can heat. So let's try to unsolder this, if it works. No, it works okay. I'm burning plastic, cold melt glue, but that's okay. Yeah, it works better than expected. A lot better than expected. Okay, this one is probably the easiest part to fix, and then we'll have a look at the sensor and what I decided to make and how I will change it. So we have ground, then we have red, green and blue. These two should be switched. And yeah, we'll need some strain relief because I see the other one already breaking. And in theory, you should solder it from the other side. I don't have the other side, and I could remove the glue, but I don't want to. Too lazy. It was well aligned, so let's try it this way. Sure, it will be good enough. Then, whoop, red. Won't last long. Oh, sorry for the bump. Red, green, blue, red, green, and blue. I like these displays. They are quite, it's very similar to I2C. It is not I2C, also because it's not open drain, but they're easy to drive. And for simple 7-segment displays, it's plenty enough. So you connect in with 4 pins, like always power and then clock and signal. So TM1637, if you're looking for them. And you can get them in lots of sizes and lots of colors. For pretty cheap, so for simple numbering displays, they're good. One, so this was clock, digital input output. So they are also, it's in this case they are only used as input because you only want to display, but the same can be used for scanning matrices. Scanning matrix, keyboard matrix, things like that, input matrix, button matrix, because the idea is that here we also multiplex the outputs, else there are too many pins, so they are multiplexed in lines and rows. And the same idea is, the multiplexing idea is also very frequently used for keyboards, keypads, whatever, whenever you have more than 4 pins for inputs. And this module can also be used for that, but I've never used it for that though. I only know it for this thing. Okay, let's test if it works before we glue it together. Yes, it works. Okay, this is the date. 2000. So it was started 2000. This should be the date today. No, there's something wrong with the date. So we are not the 16th of this September. Let's check if the voltage on the battery is fine. And as you've probably seen, the DMM now works. So the voltage on the battery should be around 3 volts. Ooh, that's low. So I don't have a good... No, 3 volts. That's okay. So the DMM works. The RTC works. Just got confused, maybe because I played with it. I don't remember. I'll just set it up. Cable. And we'll set the time and date up. So this is connected. Oh, you don't see, but I've just connected to a USB cable. And now I should have, let me check if it's there. ACM 0. Okay, let me switch this on also. You go here. And this one. Okay, so let's put this here and let's increase the fonts. Oh, no, I can. Here, total cap 33 to daily caps. Okay, there's something wrong with the counter. Date, okay. And the help, let's see how you input date. Okay, this way. Date 2022 09/22 and it's 13. Yep, this way. 5600, and let's wait until it's this time. Should take 5 seconds. It doesn't need to be precise. Up, date malformed, expected this. Okay, let's try again. Maybe it was because I did, see, you see the count. Something happens. Okay, there's a connection issue. Let's connect it again. Okay, connected. Caps detected, cross, date. What malformed? It is not malformed. Day 2022 09/22. Weekday. I need to put the weekday. We are Thursday. TH probably. And then the rest. Okay, now it's fixed. Okay, but we have 1 minute. Okay, now it's fixed. And if I look at the date, yes, it counts up the date. And yes, we have the caps, and here we see this is the debug output. We see how many times it crosses. Okay, now I have to put it back here. Somebody wrote me, is it important or not? Sorry, I'm responding. Okay, nothing too important. So, this is fixed. Now, let's have a look at the sensor. How does this machine work? This machine works by here. We have the basket which goes in. So, there are plenty of solutions how you can detect if something crosses. Generally, you have an infrared barrier. Let me get my infrared box with plenty of infrared devices, and it looks like this. I'll also show you this. Probably this is something else. I'll show you this solution. I'll show you this solution. I'll show you this solution. But the one, yeah. You've probably seen things like this infrared barriers, and you find them very often on mechanical devices inside when you want to align motors and so on. And on one side, on this side, probably you have an infrared LED which just shines, and on the other side you have an infrared transistor or an infrared transistor. When it crosses, the infrared transistor is there, and then when something like a wheel or just a switch blocks the path here, then it blocks the infrared signal, and this way you know that you are precisely in the middle. And these are good because not like micro switches, you don't need any contact, so this makes it a lot more durable, and it's also quite precise because the slits in the middle are fine. The problem is they are prone to infrared, so there's an infrared transistor here, and as soon as it receives enough infrared, then it triggers. The problem is, what is enough? And at the place I'm working in a bar, when everything is open, then you could have any infrared from any of the other light appliances. Sorry, I have to answer this. bench. So I'm back, and we've talked about the first solution here, and the problem is that they are so if you put them in a box, it's quite fine because it's closed enclosure and there is no infrared coming in. This is open because, well, caps need to go inside, so this solution is not superb. And this is in small. You have ready-made devices. This is the first solution. The same applies here. For example, this is out of a mouse. We have the micro switches for the buttons, and this is for the wheel, and the wheel has holes below, and this way this is a bit more complicated. There should be, no, there are not 4 pins. It needs to find out the direction if you scroll one side or the other side, and I think this is what this receiver is. There are 2 receivers in there, and this way you can find if it goes up or if it goes down, but the principle is the same. We have 1 infrared LED, and here we have probably 2 infrared transistors. Yeah, because there are 3 legs, and the gate is actually tied to the infrared. That's the second solution, but it is error prone to, so if it's in a closed enclosure, it's no problem. If it's open, it's doable. The next solution, I should have something like, yeah, this is the next solution. So instead of having one side on the other, you have reflection. So here we have infrared shining, and this is an infrared transistor, infrared LED and infrared transistor here. And if you have something in the front, which is, yeah, then the infrared light from the infrared LED gets reflected back to the infrared transistor. The problem is this is still error prone to, so this, at least you don't need to put a tiny slot, so you can have larger gaps because it just reflects it. But the problem is it is still error prone to infrared light. And I think, I didn't measure it though, but I think in the environment where I'm building it, this is not, there might be lots of infrared, for example, lights, lighters, and things like that. But this solution is also implemented in what you find very often in this sensor crossing. Sensor like this. So here again we have an infrared LED, infrared receiver. There are lenses, so it focuses kind of the beam. And here you can select on the back. You have a trim pot, and this selects the. Since we have plenty of small devices, let's measure. Let's try to focus. This selects the range, and if you cross the range, then it works. So this is a bit better than this module, because here you cannot select the range. You can just select how this selection is just for the LED. It's not for the transistor, I think. And here you have a range selection. So this could work, but it was rather large, so I didn't use it. Another thing, so this is the second one, and there's also this sensor. So I'll just putting the collections to see what solutions we have. We have also this, which modulates kind of the infrared, and when it reflects, when it gets it back, then it also gives you the distance using the flight of time of travel, probably. So it pulses and then it measures the sensor, but this is, it measures the distance, but this is not good for things which happens really fast when you have something falling. So what I did is to mitigate with this infrared and with this infrared noise is what you find very often in remote controls. You have infrared receivers like this. This only receives signals which is modulated at a certain frequency, very often 38 kilohertz. You have 36, 50, 56, but most of the remote controls are modulated at 38 kilohertz. So if the LED has a frequency of 38 kilohertz, here it receives the signal around 38 kilohertz. It's pretty vague how it's pretty, it's not too restrictive, so remotes work good enough. And this is what I use. So here we have the infrared emitter, and the idea is that when the infrared LED, or when the object crosses the beam, then some light is reflected back to the infrared receiver, and the infrared receiver decodes it, sees it, and gives me a signal. This is what we have here. this is the same module. So here we have, hard to see, but here we have the infrared LED, here we have the infrared receiver. And when it crosses, then the light goes on. And you have two switches here, which I never know which one does what. One sets the frequency of the infrared LED and one sets the brightness. I don't know why they fixed the frequency, not fixed the frequency at 38 kilohertz. And here we see that this is 38 kilohertz because if it tries to focus, we see VS 1238B, 1838B, and the 38 tells 38 kilohertz. And if we switch on up the oscilloscope and I try to capture the oscilloscope, multi-dashboards, oscilloscope, connecting, okay, connection refused, the oscilloscope was not up, now the oscilloscope is up, so let's switch the oscilloscope. Here we see the oscilloscope, and if I look at the LED, I should see a 38 kilohertz signal. And the glue gun. Let's do that just afterwards. I need a ground point. Where do I have ground? I have here, but this is covered in glue. I don't know if this is ground. This is not ground. I have no ground points. Come on. Here. This is a bit far away, but this is a ground point. Okay. Ground connected. And then if we look at the LED, then we should see this is the LED, but we have no power. So nothing will happen. I need some power. And normally we should see a 38 kilohertz. Why is this so flaky? Maybe because the ground connection is not that good, that there is a 50 hertz signal modulated on top of it. Probably. But let's tune it again to 38 kilohertz exactly. And because the receiver wants 38 kilohertz, and I need to figure out which one of these two it is. Not the right screwdriver. Let's take this one. Does this change the frequency? No, this changes. Yeah, this changes the voltage. So this is the voltage, this is the frequency. These trim pots are not very precise. I'm making it worse than it was. It was 3811 and I won't be able to be closer. It's just optimization issue, but the receiver should be fine. 39? $38.3, $38.2. Come on. 38.11. That's good enough. And if we look at, I think this is the output. No, this is not the output, because here when the light is, oh, you don't see anything. When the light is on, it says that it found some, here, you see I reflect something back. This is a reflection back. And that's not the one. Yeah, this is probably the, no. No, which one is the output of this sensor? And you see, it kind of doesn't, it really depends on the reflection. Probably because it's not bright enough. But here I have my finger in front. I have my finger in front of it and it doesn't shine. So this is the frequency. Let's mark it as frequency. Let's get a pen. Let's make F for frequency. And actually let's glue it because it's 38 kilohertz, which is what we write. And the other one is P, like power. P, but I'll glue the frequency down because we have 38 kilohertz and we don't need to change it. So I'll put just a glue on the side. This indicates that I should not tweak this one. Okay, that's the clear indication, which you still can't see. Okay, and then let's also put glue on this thing to have kind of a stress relief. Let's wait until it is cooled and then we put it also on the other side to have double stress relief. And I just burned the mat, but it's not a problem. So let's change. So here we see no, almost kind of a reflection, but I always want a reflection. And you see how noisy it is? There's nothing going through, and still we have plenty of reflections. And I don't know where it comes from. Probably some air particles, but I mean it's 38 kilohertz, and this sensor probably needs a couple of cycles for it to work, for it to be detected. And here it stops detecting. I have no idea how this thing works. If I increase the power, no. So what I will change is that I'll still keep this module because it's already soldered, but instead of having the infrared reflected, because we see it doesn't work well, I will unsolder this infrared receiver and I'll put it on the other side and we'll test this way. And instead of having the reflection going back, we will just check when there is no reflection. So when it is interrupted, then we will count it. So that will be my next try, because you see how now it works, now it doesn't. I have no idea. So why doesn't it keep? Now I know. Okay, this sensor, okay, this is something I didn't think about. This sensor will try to auto-tune. This is probably what we are seeing here. It will try, it is not just verifying if there is a 88 kilohertz frequency. It is trying to adapt to find out a strong 88 kilohertz frequency. This is probably what we see here. In the beginning, it reflects, and then it thinks it still receives the 38 kilohertz, but it thinks I receive it constantly. This is not the purpose of this sensor. This sensor is to detect bursts of 38 kilohertz, which is meant from which is there from remote controls. So I won't be able to use it this way. Okay. Which is therefore remote controls, because they have small bursts. And if it's too long, that it will auto-tune the minimum level and it will stop reacting. And this is probably what we see here. And why it stops reacting, although it detected it in the beginning. This is probably, let's have a look at the data sheet and see if this is actually the case. I have kind of this data sheets because I worked with this sensor in the past. Where did I put it? Sensor probably. I can search for it. 1838, something like that. Sensor module, yep. up. Okay, this is the Chinese version. This will not help. I need a not Chinese version. It's in sensor, IR, demodulator. Probably, let's have a look at this one. This is very similar. Full screen. This one, TSOP 32 something. Here we're 32, 33. And yeah, they're for infrared demodulation, carrier frequency. You see if it's end with 38 kilohertz, it's 38 kilohertz. This is most of the frequency you find. This is one of the main. And they have the automatic gate control. So here you see for long bursts, and this is legacy, but you will probably find in a data sheet here, automatic gain control. And I think this is what's happening if it receives the signal for too long. It says, this is probably not infrared burst, so I will tune my gain, and even if I receive this frequency, it's not strong enough. So I will wait until I receive the next strong enough. And it does continuous automatic gain control. Optical signal. And it always takes a bit of time. I think like here we see TD. It takes a bit of time until it detects or it outputs, but I don't know what the minimal burst is. Input burst length, output pulse width in blue. Ah, this is something else. Is there a minimum pulse length? But I think it's good enough. It's probably somewhere in the data sheet. Suitable data formats. Here, minimum burst lengths, 10 bursts, 10 cycles at 38 kilohertz. It means 3 kilohertz, and 3 kilohertz is around 0.3 milliseconds, something like that. Let's say around 0 or 4 kilohertz. Bit more than 3 milliseconds, so that's fine. I don't think the cap is going faster than that. The problem is the reflectivity. The caps reflect things differently all the time, so I would need to have something which reflects quite well, but we can test how it works. And then the maximum, here we see it. Okay, the maximum number, each bursts of length of a minimum gap required, 38, 33. Okay, and this is the minimum gap between bursts, and then we see here maximum number of continuous bursts, which is 1500. So if you have more than 1500, then it stops detecting, and this is what we see here, which I've never used it before. Bench. This is what we see here when I plug here. After a certain time, it stops, but here it's not too noisy. And the byte was very noisy, so we can try it actually. So here's a... here it's noisy. Still, you still see it blinking, although nothing happens. I think this is because this is reflecting back, or whatever here is reflecting back. I cannot use this as interrupt. I can only using as reflection, because although maximum frequency, I could also use it as interrupt, but then I would have to change the code. The problem here, this is noisy from reflections. There's no noise anymore, but if I put it here, you see there's noise. And I could, in the code, I kind of have, if it has 30 reflection, then it counts. We can actually see. We could see in the code. Let me show you the code, since I need to be connected. Let's connect it and show in the code. I don't need the multimeter anymore. Up. So let's connect this. Now I want also to add some glue on the other side to have strain protection on both sides on the cables, but we can close it because it works. I don't need to add anything new. What I would change though is this connector. I would add a connector so I can unplug and plug this thing in. Do I want to do it now? It has 4 connections. Yes, 4 connections. And here there's also a strain relief, so this is good. It's meant to be. Do I want to put a connector or no, I don't want to crimp. Too lazy for that. It should just work. Now if I put it here, so we can see there are some blinks and it's still not counting up. Oh, you have too much garbage showed everywhere. Oscilloscope, go away. And you have too much reflections, too many reflections. Here. No okay, here you can kind of see the results. And if we look here on the code, you can see the number of cross it found. So these are the bursts, the number of bursts it found. And I ask for a minimum number of activity of bursts. So if we have some bursts, like here, we have 30 bursts, I consider this as noise. And I want a minimal number of bursts until it does a true positive. And if I put a cap, there are not enough bursts. How many bursts there are? And it didn't detect it. 1 crossing, 3 crossings. So this could be considered as noise. 5 crossings. And this is what I don't want. So what I will do, and this doesn't work, here we have 6 crossings. It's not a cap, but I think it still would reflect. I mean, it's metal, or coins, but on the caps you never know if there's lots of color or not, but the coins should quite reflect well, but it's too fast. So this doesn't work. It's too noise prone. So we'll try to desolder it and put it on the other side and see if it works this way. I mean, it doesn't work the way I want, so why not see if the false positive rate is better? We have the maximum number of bursts limit, which will be a pain, but it means that so if something crosses, it needs 10 cycles to 35 cycles. What's 35 cycles? I don't know how fast this goes, but this is pretty fast. To 35 cycles, well, we'll just try it. And after 35 cycles, it can re-trigger again. And this is when I hope that when it re-triggers, because it has been blocked after the 38 cycles, then we are good for it. So let's switch off the power. Let's desolder the infrared receiver. And it is held, oh, it's held by a tiny bit of solder, but not enough, so it's blocked. It's solder, glue gun. And actually, how can it work? Because it's the wrong way. Ah, okay. It still works. It's this way. Come on. Is the solder keeping you back? Ah, let's just remove the glue. Can I? Yeah, well. What I could do, so now it's fixed, but what I thought is generating the 38 kilohertz myself. So it is set in software, and when it's set in software, then nothing can tweak, but here it's okay. I'll just try to reuse the device. Okay. Yep. I'm not sure if this will work. Let's try to remove it completely. I can glue it afterwards again, so I have better access to it. Better. Let's remove the alcohol. Let's let it flow the other side. Let's keep the hot glue gun warm, so I can re-glue it afterwards. Up. And the other sensor I thought about, but they're a bit more expensive and I didn't have, or I don't have some. There is an induction sensor. So I think it's a Hall effect sensor with a magnetic insert. So it reacts to metal. I don't know if it's fast enough though, for coins. I have it on my 3D printer. And this is how I do bed leveling. Automatic bed leveling. It just detects when it hits the bed. Come on. Do I need to solder to unsolder now? This thing is a pain. So let's put some solder so we can unsolder it. I think it's just this one. And why is my soldering iron off? I don't know. And you see, since I've last changed my USB hub, the streams are a lot more stable, which was the whole purpose. Come on, soldering iron, heat up, heat up, heat up. Yeah, instant heat. Oh yes, instant heat. Now it's heating, good. Whew. Ah, this is the ground pad. This is why it has so many issues soldering it. Or unsoldering it. Okay, so this is added. Let's try to remove it. If I heat both of them, I need to heat all three of them, and for that I need the other soldering iron, this one. Up, which has the right blade. Yeah, perfect. So let's put some solder on the last one also. This one will heat, this blade will heat all three. Okay, now it's unsoldered. Up. Probably won't need you again. Up. I will clean the holes because I need to solder some cables on it. This one doesn't want to. That's the ground one. Okay, now it did. Let's clean it up a tiny bit. Up. Alcohol. Maybe I will just really create just an infrared barrier, because if it's not reflection, but if it's crossing, it might be less error prone. We'll try with this module first. If it doesn't work, we'll do with another one and we'll just create an infrared barrier. It still has too many false positives, then, well, then I don't know. I will have to have an induction sensor, a metal sensor, but I don't think it's that hard. So we have holes on one side. Let's crack some holes on the other side. Right in front of it. That's this here, and we will put it on the bottom or on top. On top. So here will be the output, on the other side will be the inputs. Yeah. Let's solder some wires. I just need 3 wires. I have cable for 3. It's not beautiful. I have better cable for 3. Although do I care about if it's beautiful or not? Probably not. Up. So let's use it, and if I care I can still repaint it or respray it. So it will, how much will we need? From this to here with a bit of margin, this much. Up. We will try to keep the colors correct. White will be ground, red will be power, and green will be outputs. Although, maybe we just solder it as it is. Yeah. Third hand. Up. Up. Theory shrink tube, but since we will put some glue afterwards, we don't need any shrink tube. So we don't respect the signals, but it's not important. At least we respect the order. One, two. Three. We need a bit longer because it goes through the holes. At least it will try to go through the holes. And it was this way. So let's put it in this way. On the front. Do I need to tin it really? Yes, I do. Won't go in. Two, three. Okay. No, damn it. Oh, this pad is half broken. Hope it is still connected enough. Probably. So let's try it out. Power. Okay, here we have power. And it's very noisy. I thought it would be constantly on or constantly off, but not in between. Maybe I just need to put... No, okay, now it's constantly off. And if I cross it... Oh, this is a lot better signal. You probably see it. constantly off, across it, there's a long bursts. Okay, this seems to work nice. Oof. Let's put some strain relief here. So it makes long signals. Cool down. We can cool down this way also. And it doesn't need to be in front, it can be any direct, well, in front, it doesn't need to be longitude. I can keep it on the side this way. So let's try it. Oh yes. There's less false positives. Oh, but sometimes, yeah, but I have a timeout. So I can add a timeout. You see the counts on the right. So it does correctly count. I hope it is more noise tolerant. So let me show you the count. One count, we just can ignore, but this is because I'm moving. I think this is it seems to be a good solution. Let's try it in practice. So let's glue it together. Yep, let's glue it together. And let's try it out. It's one side. Up. Kind of a mess in here. Oh, I need to hold it until it cools down. Yeah. It's not instant glue. I also have a fan normally for that. Too lazy to get it. That's the other side. And to have less, I could still increase the strength of the LED or decrease it until it doesn't find it anymore. Let's wait until it cools down. Let's get the fan. Let's get a clip. That holds it together. Now we would put the sensor this way, and we don't need to, yeah, it should be enough this way. Let's try just to clip it before we can fix it. Is it long enough? That's long enough. Nice. So that seems to work okay. Let's try. No, it doesn't. Damn it. Oh, it does. Why don't I show the count? I see the red LED which went on. Count 1. Why doesn't the red LED go on? Count. Count. That works. That doesn't work, right? It was probably on this side. Yep, that didn't work. Ooh, it only works with bigger coins, not with the small ones. Yep. Even with the bigger coins it doesn't work. Do I need to increase or decrease maybe? Let's try to decrease. Is this decreasing? Oh, now it works better. Yep. Let's try with smaller coins. Yep. I just need to put... no, it didn't work. I think it won't always work. Yeah, it still didn't work. Let's try to decrease again. Okay, it worked. Didn't work. Decrease. It worked. 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 Didn't work. Worked. 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 But I think I don't have any false positives. No, I did have here. Nah. Need to increase it a bit. No, I do have false positives. Maybe because it moved. Let's fix it. I think it's a good solution, and else, if it's not, I can still make something. But the LED is not facing the basket. I want it to face directly. Somewhere along here. It's not the middle. It should be okay. Oh, I actually want this. No. The LED has the LED has a cone, so even there it should receive it. Let's try to glue it and see. It seems to be an okay solution, better than the previous at least. Oh, it's only one side. And can I, I have an infrared camera which indicates, don't care. So cool down. Let me get the fan. It's taking too long. Now I'm just making a mess because I'm too impatient. Okay, let's leave it here. I'll still get the fan afterwards, but till it holds it tight. No, now it holds enough. Up. A fan. I should have 12 volts somewhere on the back. This should be something like 12 volts. And on. Yep. And it blows this way. And it's silent. Let's put it on the other side too. Let's add again here to remelt a tiny bit. Let's hold it. Let's cool it. And I need to fix the code which does the day count. Okay, let's try it again. This should hold enough. It seems to work with bigger coins. Let's try with smaller ones. And now it doesn't care about the reflection, and the cap's a bit bigger. Ooh, smaller ones don't work. Let's try it. But bigger ones work. Not always. Wow. Let's try to decrease it. I hope this is decreasing. Yeah, I think this is. Ah, didn't work. Oh, this doesn't increase sensitivity, it decreases it. Oh. Okay, it was just not enough. Okay. Yeah. Smaller coins, cent coins barely work, but wow. And when I lay it flat, no, it doesn't work. At least there's no false negative, false positive. That's good. It works a tiny bit better. I wouldn't say it's completely fixed, but it works a tiny bit better. I need to change the code, but yep, it doesn't find everything. Let's try with lots of coins. Let's change the code. And then I also need to put a larger timeout because it waits 480 milliseconds. So where is my code? This I can remove. Data projects. Firmware, not firmware. No, it's directly here. I'll switch immediately so you can see what I'm doing. Six up. So full screen. Application. Okay. So barrier valid. Now I want just five number of crossings. Is this good? I don't know. Cross one. Yeah, I think it will still be good. And the timeout is there is somewhere when I want a timeout here. If wake up flag, if button flag, no, that's not it. Second flag, oh, I do it every, no, what's here? Here, this is it. Wake up flag, if barrier counts. Okay, barrier count 0. I need a wait for cap to fall through. Ooh, I have plenty of false positives now. What's happened there? 48. I need to put 1 second. Let's try it out. Like flash. This doesn't work. Cross 1, cross 3. Okay, this is because you tried to calibrate. Let's try if it works. Cross 2. Damn it. Doesn't. 35. That worked. Didn't work. Worked. Worked. Yeah, kind of works. This is only one crossing. Yeah, there are not a lot of false positives, so I can actually just have it if it's just more than one. Seems to be very robust. Let's lower the limit and let's put it to 2 or 3. Crossings, maybe it's just the period which is important. How long it's on and now how many crossings there are. But I would need to change. Cap detected. Okay, this is definitely a false positive. I didn't do anything and now it says cap detected. And it started increasing. Not a ton of false positives, but still some. Again, cap detected. 48, I did nothing. It didn't move. Ah, these sensors are such a pain. I would probably have to measure the time. Yeah, I'll probably have to have an infrared LED transmitter and infrared, again, cap detected, infrared transmitter and infrared receiver, and just measure the time. This does not seem to work. I'll probably use the other sensor. But I don't have any code to measure the time. Again, cross 3, cross 1. What the hell? Is it just noise on the line? Because I don't see the LED going on. Again. And the LED should be on for a long time. Is this just noise on the line? No, it's a push-pull. Oh no, I did see it blink. I did see it blink again. So the noise is still there. It's weird that this time it is only short. Yeah, too many false positives. So this solution doesn't work. Well, modulation, demodulation doesn't work. I'll probably make an infrared barrier. And then just measure the time. Let's try again. Can I do it by, if I implement time measurement, can I do it also with these coins? Yeah, but the amount of time it is didn't detect it. Didn't detect it. It's random. It really is random. Noise. Detected. Didn't detect it. No. Yes. No. 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 And this was a €2 coin. Okay, it doesn't work with this. No. Detected. Noisy. Detected. 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 Didn't detect it. Well, infrared barrier it will be. But that's for another time. I need to test a lot more and to change a lot more. It's not just a repair, so it's a stream for another time. But that's the idea of the cross detection. So yeah, don't use the demodulator if you really don't want to cross barrier. They're not stable enough. Okay, that's it for now. I'll just do something else, and if I have time, I'll do the infrared thing. I don't want to bore you with code. So that's it for the stream. Enjoy!